Hello, hi, Assalamualaikum. So now we proceed to the second part of lesson 11, subtopic 10.3, sound intensity. The learning outcome related to sound intensity is the first one, we need to define and use the sound intensity. And the second one, discuss the dependence of intensity on amplitude and distance from a point source by using graphical illustration. Okay, what is the intensity of sound? The intensity of sound is defined as the energy transported per unit time, which is energy transported per unit time is also called as the sound power across a unit area. The sound intensity is one of the scalar quantity and the SI unit is watt per meter squared. The formula to calculate the intensity is I, which is represent the intensity, equals to the energy over time or energy over time, also same as the power, divided by the unit area. Okay, if we look at this figure, let's say this is the source of sound. When the sound wave is spread out in all directions, the power is carried out by a sound wave. And then the power of sound wave will pass perpendicularly through the surface area. And let's say this is the surface area 1, this is the surface area 2. Surface area 2 has a greater distance compared than surface area 1 and the area of surface area 2 is larger compared than surface area 1. And what is the relation between the distance, the surface area, and the intensity of the sound wave? The greater the distance, the larger the area, but the intensity will become lower. Sound intensity is perceived by the ear as the loudness, and the smallest sound intensity that the human ears can detect is about 1 exponent negative 12 watt per meter squared. And this intensity is called as the threshold of hearing. To explain about the dependence of intensity on distance from a point source R, we can use the formula of I equals to power divided by area. Okay, now let's say when a point source radiates a sound, so this is the source of sound. When the point source radiates sound uniformly in all directions, so it's spread out in all directions, and there is no reflection are present, the intensity of the sound at a distance r from the source is, okay, from I equals to power divided by area. Area, we use the formula of area of the sphere because our Earth is sphere. So I equals to power divided by 4 pi r squared. And from this formula, we can conclude that the intensity is inversely proportional to the square of the distance. Distance from where? Distance of the point from the source of sound. Okay, and if we want to sketch the graph of intensity against 1 over r squared or intensity against r squared, the intensity against 1 over r squared is straight line graph. which is it shows that intensity is inversely proportional with the R squared. If you want to sketch directly the graph of intensity against R squared, this graph represents the intensity is inversely proportional with R squared. And then, as a conclusion, when far from the source of sound, the intensity will become smaller and the sound is hardly to be heard. And the second one is the dependence of intensity on amplitude. These two diagrams is the analogy about the amplitude, which is the second figure, have greater amplitude of sound wave compared than the first one. Okay. The formula to relate between the intensity and amplitude is I equals to pressure amplitude maximum squared divided by 2 rho Vm. Rho is the density of the material and the Vm is the speed of sound in the medium. And I just want to remind all of you, this formula is actually not in our syllabus. This formula is just as an extra knowledge to explain about the intensity, the relation between intensity and amplitude, which is the amplitude is like the pressure maximum. Okay. So, the relation between intensity and pressure maximum, which is the amplitude, is directly proportional. In matriculation syllabus, you just need to know that the intensity is directly proportional to the amplitude square. To illustrate the graph of intensity against amplitude, if we want to sketch the graph of intensity against amplitude or intensity against amplitude square, this graph will show the dependence of intensity on amplitude, which is the larger the amplitude correspond to high energy wave, which is high intensity, and for a small amplitude correspond to low energy wave, which is low intensity. That's all for this lesson. Thank you very much.